Dear children, in this session we are going to discuss about inverse trigonometric functions, the second chapter in our textbook. In class 11, we have studied trigonometric functions, graphs of trigonometric functions, identities of trigonometric functions, and solutions of trigonometric equations. Now, we are going to discuss inverse of trigonometric functions. When a function is said to be invertible, a function f from R to R or any set A to B is invertible if and only if it is a bijection. So that point should be in our mind before going to inverse trigonometric functions. Now let us start with the inverse of sine function. Consider the sine function f defined by f from R to close interval minus 1, 1 given by f of x is equal to sine x. We have to find the inverse of this f of x is equal to sine x. Let us take the graph of sine x. You can see here, my question is that whether the sine function is a bijection. See, this is the graph of sine function. Okay? The range of sine function is minus 1 to plus 1. Sine function oscillates between minus 1 and plus 1. Whether the function is bijection is 1, 1 and on 2. Of course, it is on 2 because all values between minus 1 and 1 are taking the function. That is, the range set is minus 1 and plus 1. It's clear. So, it is on. Whether it is 1, 1, let us check. See, here, for this particular value of x, there are this value, this point and this point. On all these points, the line is cutting the graph of sine x at different points. So, if it is a point x1 and this is x2 and this is x3 and here x4, for all these values, f of x, that is sine x, is taking the same value. So, it is not 1, 1, it is a many one function. You can see that. So, you can see that the line in all these cases. So, f of x is taking different values. So, function is a many one function. So, it is not invertible. A function f is said to be invertible if it is 1, 1 and on 2. Clearly, it is on 2, it is not a 1. Now, we have to find the inverse also. What I am going to do is, I am going to restrict the domain in such a way that the function is 1, 1 and on 2. See, if I am taking the domain as, here it is minus pi by 2 and plus pi by 2. If I am taking the domain as between minus pi by 2 and plus pi by 2, you will get the value between minus 1 and plus 1. So, if you restrict the domain to minus pi by 2 to plus pi by 2, close interval, minus pi by 2 plus pi by 2, the function will be bijection 1, 1 and on 2. Otherwise, if you restrict the domain to pi by 2 to 3 pi by 2, that case also the function takes values between minus 1 and plus 1. So, again it is 1, 1 and on 2. If you are taking 3 pi by 2 to 5 pi by 2, in that branch also the function is a bijection. So, if you restrict the domain in such a way that the function f is 1, 1 and it is of course it is on 2, but 1, 1, then the function become an invertible, that sin f of x equal to sin x is invertible. So what we are doing here, we are restricting the domain to this case. Now at present you can see that here in this branch the function is a 1 1 and on 2, so hence it is invertible. Not only in this branch, suppose I am taking this case in here. So here it will become minus 3 pi by 2 to pi by 2. Here also the function is 1 1 and on 2. Now we are taking the next branch. In here also the function is 1 1 and on 2. In this branch that is a pi by 2 to 3 pi by 2. And if you take in this branch also that is 3 pi by 2, 5 pi by 2, also the function is 1 1 and 2 and so on. In all these branches the function is a 1 1 and on 2. Is it clear? That is, from the graph it is clear that f of x is equal to sin x is many one arm to, hence not invertible. If we restrict the domain R into any one of the interval minus 3 pi by 2, minus pi by 2, or minus pi by 2, pi by 2, or pi by 2, 3 pi by 2, or etc., the function become a bijection, hence invertible. Is it clear? Now, not necessary to see graph of sine function once again. Now, we denote the sine inverse of sine by sine inverse. And another word of sine inverse is arc sine. Sine inverse or arc sine. Thus, sine inverse is a function whose domain is minus 1 plus 1. And the range could be any of the sub-intervals minus 3 pi by 2, minus pi by 2, or minus pi by 2, pi by 2, or pi by 2, 3 pi by 2, and so on. Corresponding to each such interval, we get the branch of the function sine inverse. The branch with a range minus pi by 2 to pi by 2 is called the principal value branch. It is called the principal value branch. The principal value branch. In this interval, minus pi by 2, closed interval minus pi by 2, pi by 2, that branch is called the principal value branch, whereas the other intervals as a range give different branch of sine inverse. Is it clear? Now we are going to define sine function. Sine inverse. The sine inverse is from minus 1 plus 1 to minus pi by 2 to pi by 2 defined by y is equal to sine inverse x implies and implied by sine y is equal to x, where y element of minus pi by 2 pi by 2. To avoid that gap between the f of x, sin x and sine inverse, I am connecting this to the function and its inverse. Relations and functions inverse. You can see here. Now, what about a sine function? Sine function, actually it is from R to R. Now we have restricted that domain to minus pi by 2 plus pi by 2. So it is minus pi by 2 plus pi by 2 to close interval minus 1. Let us connect this with the function. Suppose f of x, f is a function, f of x is defined from a to b. Then f inverse is defined from b to b. And if f of x is equal to y, we write f inverse of y is equal to x. The same thing is for here sine function also. So sine is from minus pi by 2 to minus 1 plus 1, close interval minus 1 plus 1. So it's inverse. If f is the function, f inverse. So sine is the function here, sine function. So sine inverse. So what about sine inverse? Sine inverse should be from word to word -1 plus 1 to minus pi by 2. So -1 plus 1, the domain is -1 plus 1 and the range become minus pi by 2 pi plus pi by 2. Now, f of x is equal to y implies f inverse y is equal to x. So, sin y is equal to x implies what you will get? Sin inverse x is equal to y. Now, continuing, the domain of sine inverse is -1 plus 1 and its range is minus pi by 2 plus pi by 2. Now, f composition f inverse or f of f inverse of x is equal to x. Same way, sine of sine inverse of x is equal to x, where x is in the domain -1 plus 1, domain of sine inverse. Same way, f inverse of f of x will be equal to x. So, sine inverse of sine y is equal to y, where y element of minus pi by 2 plus pi by 2. These are the three important points. Now, what about the graph of sine inverse? Graph of arc sine inverse. Graph of sine inverse. Let us see here the graph of sine inverse. In the GeoGebra we can see. See, this is the graph of sine inverse. Let me zoom it. So this is the graph of sine inverse. So you can see that in the case of a sine, the x-axis pi by 2, minus pi by 2, etc. it is the mark. But in the sine inverse, it will be in the y-axis. So x-axis become y-axis and y-axis become x-axis in the case of sine inverse. So here it become minus pi by 2 and here pi by 2. So the graph is, this is the graph of a sine inverse. Actually, what is the graph of sine? This is the graph of sine. This is a graph of sine. But I told you that this graph is in the principal value branch. So the sine inverse can be defined in the remaining branches also. That is from pi by 2 to 3 pi by 2 or 3 pi by 2 to 5 pi by 2. So sine inverse range can be marked as pi by 2 to 3 pi by 2 or 3 pi by 2 5 pi by 2 or minus 3 pi by 2 minus pi by 2 etc. If it is so, what will be the graph? If you join that graph, what will be that? See, if the range is considered as pi by 2 to 3 pi by 2, it is pi by 2 and 3 pi by 2 here, so it becomes in this way. If it is taken minus 3 pi by 2 minus pi by 2, so the graph will be coming in this way. So what will be that graph? That graph will be, this will be the graph. This will be the graph if we joined all these branches. The graphs of sine inverse in all these different branches. Okay? This red color graph is the graph of sine inverse in the principal value branch. I think it is clear now. So that is, we have discussed sine inverse and the graph of sine inverse. Now graph of sine inverse and graph of sine, there is a relation. It is the mirror image about the line y is equal to x. Let us see. So in the GeoGebra you can see the graph of sine inverse. Sorry, sine. This is the graph of sine. This is the graph of sine. And this is the line, the bracket. This line is the line y is equal to x. Okay? I am taking a point A in the graph of sine x. This is the graph of sine. I am taking the reflected image, reflection of A with respect to the line. The reflection of A with respect to line y is equal to x is a dash. Now if we move this A dash also will move because it is a reflection. Let me see what will happen here. Now you can see that the point A is moving, so we get the point A dash also. See that. So this is the graph of a sine inverse. This is the graph of sine inverse, and this is the graph of sine. This is the line y is equal to x. Now it is clear that graph of sine inverse is the mirror image or reflection of graph of sine with respect to the line y is equal to x. Now it is clear. The same picture is in our textbook. Now let us define the inverse of cosine function. The same way, let us we know that the cosine function, the domain is R and range also -1 plus 1, because cosine function also oscillates between -1 and +1. So consider the cosine function f defined by f from R to -1 plus 1 given by f of x is equal to cos x. My question is that whether the cosine function f of x is equal to cos x in this domain and the range is invertible. Let us see. Let us take the graph of y equal to cos x. This is a graph of y is equal to cos x, where domain is a set of real numbers and range is -1 to +1. Range is -1 to +1. Clearly, the function is not 1 because it's onto, because between -1 and +1, all the values of the graph has taken the values between -1 and +1, so it is onto, but it is not 1. We can check it as whether it is 1 or not. So if I am drawing a line here parallel to x-axis, the line intersects the graphs at different points, so it is a minimum function. So at present, the function y is equal to cos x is minimum onto. We have to make it as 1 onto, then only the function is invertible. How to make this 1 and onto? Just like in the sine inverse, we have defined the sine inverse case, the same way we have to restrict the domain. How to restrict the domain? Let us see. This is the case. Now the cosine function takes values between -1 and +1. If you restrict the domain, actually the domain is set of all real numbers. If you restrict the domain from 0 to pi, if you restrict the domain from 0 to pi, the cosine function takes values from -1 to +1. So in that restricted interval, subinterval, the cosine function by f of x is equal to cos x is 1 as well as onto, hence invertible. Otherwise, if you restrict the domain to pi to 2 pi, then also the function is 1 and onto, hence invertible. If you restrict it 2 pi to 3 pi, then also it is 1 and onto. Or in the same case in the negative branches, -pi to 0, the function is 1 and onto. So in all these branches, the function f of x is equal to cos x is a bijection, hence invertible. I will show you the branches, restricted branches. This is the one of the restricted branch. In this branch, it is 1 and onto, and again, if you take this branch, again it is 1 and onto. So in that way, we can restrict the domain to make the function 1 unknown 2, hence invertible. I am closing this GeoGebra. Dear children, when we are studying inverse trigonometry functions and trigonometry functions, connect everything as far as possible to its graphical view. So it will be permanent in our mind. So from the graph we have seen that the function f of x is equal to cos x is many one on 2, hence not invertible. If you restrict the domain R to any one of the interval minus pi to 0 or 0 to pi or pi to 2 pi or etc., the function become a bijection, hence invertible. So in that branches it is invertible. This is again graph. We denote the inverse of sine function, just the inverse of cosine function, sorry. So there is a correction. This is a not sine function, it is cos. Inverse of cos function is cos inverse arc cosine. That is another name. And this cos inverse is a function whose domain is minus 1 plus 1 and range could be any of the intervals minus pi to 0, otherwise minus 2 pi to minus pi or 0 to pi, pi to 2 pi and so on. Corresponding to each branch, we get a branch of cos inverse. But the branch with a range 0 to pi is called the principal value branch. The principal value branch. So the principal value branch of cosine function is a close interval 0 pi. You just think about what is the principal value branch of sine inverse. Principal value branch of sine inverse is minus pi by 2 plus pi by 2. Whereas principal value branch of cos inverse is 0 to pi. Thus, cos inverse from minus 1 to 1 to 0 to pi defined by y is equal to cos inverse of x implies and implied by cos y is equal to x where y element of 0 to pi. This is just the procedure of writing inverse. Actually, cos is from 0 to pi to cos. What is cos? I shall write here. The cos is from cosine function is defined from 0 to pi to minus 1 plus 1. So what will be cos inverse? Here the range become domain of inverse and domain become range of inverse. That is A. Now, some important points. The domain of cos inverse is minus 1, 1 and the range is 0 to pi. They have the result f composition f inverse. Otherwise, f inverse of x is equal to x. So same way, cos of cos inverse of x is equal to x, where x element of minus 1, 1. Same way, f inverse of f of y will be equal to y. Same way, here, cos inverse of cos y is equal to y, where y element of 0 to pi. These are the important points in the case of cosine function. Now what will be the graph of arc cos inverse? Arc cos means cos or cos inverse. The graph of arc cos inverse is, you can see that in the part. It is where the graph, this is the arc cos, otherwise cos inverse. Arc cos, otherwise, I should zoom it here. You can see that this is the graph. This is the graph. So, actually, the domain is minus 1 to plus 1 in the case of cos inverse, and the range is 0 to pi. Now, what will be the graph of cos? I am drawing the graph of cos also here. This is actually the graph of cos, and this is a graph of cos inverse. That nothing, just